Is it clear? Shall I tell you the fourth point? Okay, listen carefully, write down the fourth one. Write down the resultant of two vectors A and B. The resultant of two vectors A and B can have value between the resultant of two vectors A and B can have value between A minus B to A plus B. Can have value between A minus B to A plus B. Everyone note it down? Okay. Now look here. Look here, the next one. Now look here. The fifth property, what it says, that let's suppose this is one vector. This is one vector, A vector. And let's suppose this is another vector, B vector. This is another vector, B vector. So what is going to be the resultant? So can I say that resultant, let's suppose this is some resultant vector. Is it right? Can I say that resultant of A and B will be? Can I say that resultant of A and B will be this R vector? Is it right? Now let's suppose if I want that the summation of the vectors which are going to be 0, means if I want that, let's suppose I have to add one more vector so that sum of all the vectors are going to be 0. So can I say that this is the resultant of A plus B if I am going to put a vector which is going to have the same length but in opposite direction? Let's suppose this is C vector. So can I say that A vector plus B vector plus C vector will be 0? Can I say that? Because the resultant of A plus B is in this direction and let's suppose 5 units. So can I say that C is having the same 5 units but in opposite direction, and if I'm going to add, can I say that I will get 0? Is it right? Guys, is it right? Now, try to understand in second way. Let's suppose if I use the triangle addition law. So can I say that this is one vector, this is another vector, B vector. Can I say that? Because if you look, this is A vector, this is B vector, resultant of A plus B in this direction, and same magnitude but opposite in sign, vector C is it Guys, is it visible? Is it visible, this one? Okay, listen what I'm saying. That let's suppose one vector is A vector, another vector is B vector. So can I say that if this is A vector, this is B vector, then the resultant of these two vectors is this one. This is the resultant vector. Now, if I put a same vector in this direction, can I say that this resultant and this C vector will be cancelled out and I will get the total summation 0? Is it right? Means if I am going to sum A plus B plus C, I will get 0. Is it clear? Is it clear, guys? Because if you look, vector C is having head in this direction. Vector B is having head in this direction. Vector A is having head in this direction. Means they are cyclical in nature. And guys, can I say that they are coplanar? Because if you look, all the vectors are in the plane of the board. Can I say that they are coplanar? Coplanar means all the vectors are going to be in the same plane. So can I say that all these vectors A, B and C vectors, they are in the plane of the board? Is it right? So everyone write on the fifth point. The minimum number of coplanar vectors. The minimum number of coplanar vectors whose sum is 0. The minimum number of coplanar vectors whose sum is 0 is 3. Is 3. The minimum number of coplanar vectors Fifth point, guys, have you noted down, everyone? Okay, listen, fifth point I'm saying. Fifth point. The minimum number of coplanar vectors whose sum is 0 is 3. The minimum number of coplanar vectors whose sum is 0 is 3. Everyone noted? If we take two vectors whose magnitude is equal but opposite in direction, then their sum is also 0. Okay, Muhammad Ayan, that's right, good. Guys, have you noted down the fifth point? Okay, look here. Now Muhammad Ayan is saying one thing, that if two vectors are going to be there and If their magnitude is equal, then also 0. Guys, okay, that's correct. Just write down, just note one word. The minimum number of coplanar unequal vector. You can add one word so that it is going to be perfect. Write down the minimum number of unequal coplanar vectors whose sum is 0 is 3. So everyone just add a word unequal. Otherwise, minimum number will be 2. Did you guys get it now? The minimum number of unequal coplanar vectors whose sum is 0 is 3. This is the fifth point, and you can draw this diagram. Fifth point, everyone noted? Meaning of the sentence is that, let's suppose if I'm having one vector and I'm having one another vector. If their magnitudes are different, then if let's suppose I'm trying to add one vector in such a way that taken the minimum required vectors, and if they are not equal, then it is not possible that you are going to get their summation 0 if less than 3. Did you get it? Okay, guys, listen. We are having network issue. All right, listen. We are having network issue now. Start solving exercises. Board is going to be clear and define clearly. Guys, whatever the homework I have given is start solving that. Whatever the homework I have given in the starting of the class, because network is not good today. Did you guys get it? And once it is going to be visible clearly, then just let me know. We will discuss this fifth point. Have you guys noted down this fifth point? Everyone, have you noted? Okay, good. Then once network is going to be fine, I will explain this. Fifth point I will explain. After this, 2-3 more points are there which we will see. So till then, start revising the notes, and whatever the homework I have given you in the starting, start solving them. Don't waste your time. Fourth point, Lucy Balloon. Fourth point is very easy. I told you that R minimum, the minimum value of the resultant is A minus B, and the maximum value of the resultant is A plus B. So can I say that if I am going to have addition or the resultant of two vectors, the value of resultant will be in between A minus B to A plus B, because this is the maximum value, this is the minimum value. Let's suppose I am saying that, look here, let's suppose I am saying that you can have minimum money that is 10 rupees and maximum money 50 rupees. So can I say that at any time, if I am going to ask you the money, if you are having, you can have from 10 to 50, is it right? Because minimum you can have 10 rupees, maximum 50. So can I say that at any time the value of the money which you are going to have, that is 10 to 50, the same thing, R minimum this, R maximum this. So value of resultant will be between A minus B to A plus B. Is it right? Okay, guys. When network is going to be proper, then I will explain these 2 points. Fourth and fifth point I will explain again. Did you get it? Fourth and fifth point I will explain again when it is going to be fine. Is it fine? Am I visible and audible? Right, just let me know. Guys, shall I tell you the fourth and fifth point? Okay, so listen here. Fourth point, what was that? That I told you that R minimum, the minimum value of resultant can be A minus B, and maximum value of the resultant can be A plus B. So can I say that any time if I'm going to calculate the resultant of any two vectors, its value is going to be between A minus B to A plus B, because this can have the minimum A minus B, maximum A plus B. So can I say that it is going to be always in between? That was the fourth point. Now fifth point, they are saying that, let's suppose if I am having three unequal vectors, let's suppose I am having two unequal vectors. So if I am going to add them, it is not possible that I am going to get 0 because they are unequal. So even if I am going to put them opposite, it is not going to be 0. Means I need at least 3 unequal vectors so that their summation is going to be 0. Is it clear? This is what they are saying in the fifth point. Is it clear? The minimum number of unequal coplanar. Unequal means whose magnitude is going to be different, and coplanar means they are in the same plane. Means if you look, these 3 vectors are in the plane of the board. Is it clear? Fifth point clear, guys? Okay, shall I tell you the sixth point? Shall I tell you the sixth one? Okay, write on the sixth point, everyone. Write on the sixth point. The minimum vectors are going to be in the same plane. So can I say that this, and if you look, I have drawn A, B, and C on the same plane. If let's suppose I'm saying that, let's suppose this is one vector A, This is another vector V. And let's suppose vector C, I am saying that let's suppose vector C is coming out of the board. So can I say that now this is not in the same plane? Is it right? Can I say that now this is not in the same plane? Means if they are going to be in the same plane, then they are going to be said to be coplanar vector. Clear to everyone? What is coplanar? Mohammad Ayan, what is not correct? Can you let me know? Mohammad Ayan. Listen here. Write down the next point, the sixth point. Write down the sixth point. The minimum number, write down the sixth point, guys. The minimum number of non-coplanar vectors. The minimum number of non-coplanar vectors whose sum can be zero. The minimum number of non-coplanar vectors whose sum can be zero is 4. Whose sum can be zero is 4. Everyone noted? The minimum number of non-coplanar vectors whose sum can be zero is 4. Everyone noted on the sixth point? Right. Now listen what I'm saying, that sixth point is the minimum number of non-coplanar vectors whose sum can be zero is 4. Now, like let's suppose, let me give you an example. So they are saying now this time they are not saying it is unequal or equal, because it is going to be for correct for every type, whether it is equal vectors or unequal. So let's suppose one vector is A vector, one vector is B vector, right? One vector is A vector, one vector is V vector. Now let's suppose vector C is outside. So can I say that vector A, vector B will have resultant like this, and vector C is going to be like this, then the resultant will be somewhere here. So can I say that for these three, look here, for these three vectors, A vector, B vector, and one vector C vector which was outside. So can I say that resultant of these three vectors will be somewhere here, and which is out of the plane of the board, means ABC were non-coplanar. So can I say that the fourth vector I am going to join opposite to it, so the sum may be zero. So can I say that minimum required is 1, 2, 3 and one opposite, that is 4. Is it clear? Did you guys understand? That is 4 coplanar non-coplanar vectors are there, then only their sum can be 0. 0.5 and 0.6. Niharika, in 0.5 they are saying that let's suppose if three vectors are coplanar, means if I want that vector summation is going to be 0, the minimum required vectors are 3 if they are non-equal and if they are coplanar. Means if let's suppose this is vector A, this is vector B, and this is vector C. So can I say that all these three vectors are in the plane, and if their magnitude are not equal, then minimum this much required so that their vector summation is 0. Let's suppose if I'm talking about 2. So they are saying that non-equal means unequal vector. So can I say that mod A not equals to mod B? Now there is no possibility when A plus B is going to be 0, because if you look, B will be something else, A will be something else. So can I say that if this is something else and if this is something else, if I am going to add, I will get a resultant. So it is not possible that if both are going to be in the coplanar means in the same plane, and if their magnitude is not equal, then summation becomes 0. Means can I say that minimum required 3, fifth point clear? Minimum required vectors are 3 if they are coplanar and non-equal, so that their sum can be 0. Now the next one they are saying that if they are non-coplanar. So non-coplanar means, let's suppose I am having one vector B vector and one vector A vector. So can I say that its resultant will be somewhere here? Guys, can I say that the addition of two vectors resultant is going to be here? Is it right? Now look here. Can I see that vector A and vector B are coplanar? They are in the same plane. Can I see that? Okay. Now let's take another vector which is non-coplanar. So can I say that this is the resultant vector? Look here. This is the summation of A and B. This is the resultant vector, and I am adding one vector which is coming towards you. So can I say that now this is non-coplanar vector? Is it right? Resultant and C, these are non-coplanar, and can I say that resultant of these two are going to be in somewhere here? Can I say that it will be something like this? So can I say that this is nothing but the resultant of three vectors who are non-coplanar, right? This is, so can I say that fourth I have to add in opposite direction, and if the magnitude of the fourth one is going to be equal to the resultant of 3, then summation becomes 0. Means minimum how much required? 4 vectors if they are non-coplanar. Clear? Guys, is it clear to everyone? Okay. Now if I talk about the 7th point, look here, if I talk about the 7th, what 7th point says that? What 7th point says that? Let's suppose if I want to calculate A minus B, A vector minus B vector, how we are going to find out? How we are going to find out A vector minus B vector? Is it feasible? Shall I continue? Okay, all right. So till point 6 clear to everyone? Everyone noted until point 6 clear to everyone? Okay. So guys, when it is going to be visible, just let me know. We will discuss point number 7. Once it will be clear, just let me know. We will calculate point number 7. Is it visible now? Okay, all right. So once it is clear, let me know. Anyway, we have discussed 6 points. We are having only 2 points remaining, that is point 7 and point 8. Then these important points are going to be finished and we will try to solve some questions. So once it is visible, just let me know. We will discuss these 2 points. Guys, are you coming to college from first if it is going to open? I don't know, guys. That's what I'm saying. That if it is going to open, then are you guys coming there? Sami is saying no. Why, Sami? What happens? I don't know, guys. Okay, guys, listen. 6th point someone is asking. Listen, 6th point was the minimum number of non-coplanar vectors whose sum is 0 is 4. 6th point was the minimum number of non-coplanar vector, the minimum number of non-coplanar vectors whose sum can be 0, whose sum can be 0 is 4. Now, have you noted whoever was asking point number 6? Guys, have you noted point number 6? Yeah, Akash, I know that it is not given. That's why I'm not discussing the point number 7. That's why I'm not discussing. Right, whoever was asking point number 6, have you noted down? Okay, I see you in the next class. Thank you, everyone.
Thank you.